All right, welcome to the next video. Good evening, everybody. Um, well, in this video, I'll be talking about this example number II. So this one said that absolute value of AB is equals to absolute value of A, absolute value of B for all A, B, and R. Well, it took me time to do the typing and everything. Now I'm just kind of only explaining. So to show this, we consider the following condition. Actually, we are going to consider five conditions here. When A and B are individually greater than 0, when A and B are individually less than 0. And the other condition, condition C, when A is less than 0 and B is greater than 0. Condition D, when A is greater than 0, B less than 0. Condition E, when any of them is greater when any of them equals 0. So actually when we consider these cases, when okay, the following cases, when A and B is greater than 0, when A B is less than 0, when A is less than 0, B greater than 0, when A greater than 0, B less than 0, and when any of them equals 0. So those are the cases that we're going to consider. Well, but before then, before we go over there, I want to show us some things because we are still going to be proving what is on the screen right now. First, we need to show something. We have already know that 1 is equals to 1 divided by 1, and 1 can be expressed as b over b, anything over that same thing. 1000 over 1000 is still equal to 1. Okay, so I made a mistake here. Here is supposed to be where b is a variable. See, one of the advantage of this LaTeX is you quickly here you go to source, just see it here, you change it change it like ASAP, just to be to be and I made a mistake here saying that where x is a variable, but now where b is a variable that can change at any time. Again, a times 1 is equals to what? A times, of course, we know that a times 1 is equals to a, which implies that a times b over b is equals to a. And that is correct. So, meaning that absolute value of a is also equal to absolute value of a times 1, which is equal to absolute value of a times b over b. And that is correct. So now that implies that absolute value of a, now instead of me to write a times b over b, I express this b over b as b times what? B raised to the power negative 1, because b raised to the power negative 1 is the same thing as 1 over b. That is indices. Yes, of course, we know that. I proceed. So absolute value of a now is equals to absolute value of a times b times absolute value of b raised to the power negative 1. So when you multiply both sides by the absolute value of b, what we have here is absolute value of a times absolute value of b is equals to absolute value of a times b times absolute value of b raised to the power negative 1 times absolute value of b. Now, the absolute value of b and absolute value of b raised to the power negative 1 are going to cancel each other, are going to cancel off. So we have here that absolute value of ab is equals to absolute value of absolute value of a, absolute value of b will now be equals to absolute value of ab. I don't know if you don't understand what I just explained, play back the video and look at the solvings to get that. So the first condition, the first case to consider is when a and b is greater than 0. Actually, that one is not even among the cases to consider. So the first case to consider is when a and b are individually greater than 0. So mind you that if a is greater than 0, b greater than 0, meaning that the product of the two of them is actually going to be greater than 0. That is correct. And a is greater than 0. Again, a is greater than 0, b is greater than 0, meaning that absolute value of a is equals to a and absolute value of b is equals to what? B. You understand? So then the absolute value of a, which is equals to a, times absolute value of b, which equals to b, we just give we the same thing as absolute value of a, absolute value of b equals to what? AB. Absolute value again, absolute value of a is equals to a, absolute value of b is equals to b, which implies that absolute value of a times absolute value of b is going to give us a times b, and this thing here is equivalent to absolute value of equivalent to 1. So we continue. Since a and b are greater than 0, it implies that the product of the two of them is greater than 0. Then absolute value of AB, which is equal to AB, is also greater than 0. Now, now I want you to look at this place very well. Say A and B are individually greater than 0, which implies that the product of the two of them is also greater than 0. When we now take the absolute value of the product, it will also be what? Greater than what? 0, which is equals to AB, because they are greater than 0. So therefore, absolute value of A, absolute value of B is equal to AB, which is still equal to absolute value of the product of AB, which implies that AB, absolute value of A, absolute value of B equals absolute value of AB. Now, since we have considered this case, we can say for all AB in R, when A is greater than 0 and B is greater than 0, that absolute value of AB equal to the absolute value of A, absolute value of B. So we go to the second case to consider when A is less than 0, B is greater than 0. Now again, since A is less than 0 and B is greater than 0, which means that negative A times B is going to give us negative AB. Of course, it is less than 0. Now, but there's something else I want us to understand. That absolute value of the absolute value of any negative number is also a positive number. So the absolute value of negative A is equals to A, and the absolute value of the positive B is equals to A. Now, that implies that absolute value of negative A multiplied by B is going to give us what? A times B. Because absolute value of negative A is equals to A, and absolute value of B is equals to B. Now, which implies that absolute value of negative A, absolute value of B is equals to what? AB. Now, again, A is less than 0. Now, absolute value of negative A is equals to A, and absolute value of A is equals to A, which implies that absolute value of negative A is equals to A, which also equals to absolute value of A. And the B is greater than 0, meaning that absolute value of B is equals to what? B. Thus, negative AB is less than 0. Yes. Then absolute value of negative AB is equals to AB, and is also greater than what? 0. Therefore, absolute value of negative A, absolute value of B is equals to AB, which equals which also equals absolute value of negative AB. That implies that absolute value of A, absolute value of B is equals to absolute value of AB. Thus, since we have considered this case and we see that even if A is a negative number, even if A is less than 0 and B is greater than 0, that it still satisfies the condition given. It still satisfies the inequality the question. So we can say thus for all A, B in R, when A is less than 0 and B is greater than 0, that AB, the absolute value of AB equals the absolute value of A, absolute value of B. So we consider the third case. The third case says when A is greater than 0, B is less than 0. The third case is just the reverse of the second case, but just that here that B is the one that is less than 0. Just that here B is the one that is less than 0 and A is greater than 0. So it's just the same explanation, the same working. Wherever you see negative A, you remove negative sign and put wherever you see B, you add the negative you put the negative sign there. So we go to the fourth case. The fourth case says when A is less than 0 and B is less than